In this video, we'll draw the resonance structures for carbon monoxide, CO. In a general chemistry setting, we really don't think about resonance structures for carbon monoxide. This is a bit tricky though, so let's take a look at it. So let's first draw the Lewis structure as you would in general chemistry. Carbon's in group 14, sometimes called 4A. It has 4 valence electrons, and then the oxygen, group 16, sometimes called 6A, 6 electrons. So we have 10 valence electrons for this carbon monoxide here for the Lewis structure. So let's put 2 electrons between the carbon and the oxygen. That forms the bond here. And then we'll put 2 here. Completed the octet on the oxygen. We used 8. And then 2 over here on the carbon. So the oxygen has an octet, but the carbon doesn't. So typically we'll just move some electrons to the center here, create a double bond. Oxygen still has 8, carbon has 6. Let's move 2 more of these electrons, create a triple bond. Then we'll move these up here. So in general chemistry, you end up with the octet on the carbon and on the oxygen. You've used all 10 valence electrons. It's a good Lewis structure. But there's one drawback to this Lewis structure. If you calculate the formal charge, carbon would end up -1 and the oxygen would be +1. So we'd rather have 0 formal charges if possible. And usually we'd expect the negative formal charge on the more electronegative element, like oxygen here. So let's draw the other resonance structures and see how that works out. So instead of a triple bond, we could have a double bond here. And in this case, the oxygen, it has an octet. The carbon, though, only has 6 electrons, 6 valence electrons here. We've used all 10. So from the standpoint of an octet, this isn't very good. But if we look at the formal charges, we end up having the formal charges both being 0. So that's an improvement from what we had before. We could also draw this another way. We could have this pair of electrons here. That would be another resonance structure. So let's do that. One last resonance structure. We could have a single bond between the carbon and the oxygen. That would look like this. Still using the 10 valence electrons, the oxygen, it has an octet. Here the carbon only has 4 valence electrons. If we looked at the formal charges, we'd have a +1 here and a -1 on the oxygen. So from the standpoint of having an octet, this isn't very good. But now we have the negative formal charge, at least that's on the oxygen. So these are the resonance structures for CO, carbon monoxide. If you look at the structure for carbon monoxide experimentally, you'll find that it's an average of these structures. It contributes about 50% to the final structure. These two structures here, about 40%, and then this one here, about 10%. So we'd average all of these Lewis structures, these resonance structures for carbon monoxide, but we'd weight the average. So it would be mostly this structure here, then these, and a little bit of this. And you'd have just one final structure, and that would be what you would see in the lab if you studied this and were able to deduce the actual structure, the physical structure. Note that there's a link to a website where I got these numbers in the description. So these are the resonance structures for carbon monoxide. If you're in a general chemistry class, they're going to expect you to do this one. But do understand there are other resonance structures, and there are reasons for that. This is Dr. B. Thanks for watching.